Okay, so let's start with question number 37. Let's get a white screen, get rid of that. There we go. Okay, so this is blue pen. And this is question number 37 from your GED book. And it is on page 593 as well. So let's read the question, and then what I did is I drew a graphic of the cone that we're going to be using. But if you have your book, follow along in your book. And the question reads, the right cone shown below has a base with a radius of 6.4 centimeters. And you can see that here. Let's see if we can go back out to it. Yep, right here. Okay, so let's see if I can get my pen. Okay, that's what we're talking about here. That's your base. If that cone was sitting flat, all right? And you can see 6.4 is the base, and then it have 12 centimeters as well. And that's more than likely, we haven't got to the problem yet, but they're probably going to tell you that it is the what? Probably going to be the height, all right? So we can see from the base to the tip, probably going to be the height. So, to the nearest cubic centimeter, here's what they want to know. What is the volume of the cone, right? Okay, so we have a formula for that. A, B, C, or D. Here's what we're going to do first. Let's go back to the whiteboard. So let's write the formula. Volume of a cone, V equals 1/3 pi radius square height. Okay, so that's the formula we're going to use. Now, let's use that formula and plug in what they gave us in the problem. So, we'll start here. V equals, because we're looking for the volume. Volume equals 1/3 pi, so let's put pi in, 3.14 times radius square. They gave us the radius, which was 6.4, right? Okay, let's close pi and put the radius square in there. 6.4 square and the height, that's what we thought. The height is 12 centimeters. 12. And then guess what we're going to use? Orders of operation. Okay? So now, we've plugged in our values. Let's work the problem. Now, I've seen people do this different ways, but the way I saw this done in the book, they set everything over everything that you see in this problem was set over. Let me give me a little red pen. You see here? They took this whole problem and set it over 1/3. So here's what they had. They had this. They put a 1 here in front of the, so they had it like this. Let's say the 1/3 was out of the way. I'm just showing you, then we're going to redo it. They had a 1 there, in parenthesis with time. And then they put the 1/3 as a denominator like this. when they rewrote it, I just want to show you this so you can do it either way. And they moved that. When they rewrote it on the next line, right? All right, I'll show you what they did. Okay, so let me get it back. When they rewrote it, they did this. 1. If they were going to the next line. And they had everything set over 3. You see? And they worked it like that. So we can do that. But the other way I've seen it done was this. Let's see if I can get rid of that. No big deal. You know what we're doing here. Let's get rid of this. And be careful with the zero because I don't want to take too much of what I'm trying to do away. Okay, come on. Gotcha. Okay, now. Blue pen. Make the V, you know, it's volume. It's a V. Equal. Okay. So the other way I've seen it was 1/3 times. Let's put it back to where it was. 1/3 times what's to the right. You see? But you know when you multiply this 1/3, you can convert it to a decimal, and so it'll be saying that decimal, I think, is going to be 0.333 times everything to the right. All right, so let's go ahead and do the problem. So the next line, we're going to write it. This is the original problem right here, the way they have it. So then we write it like this. Next line, V equals 1, because I've shown you both ways to have it. Bring everything down, 3.14. And 6.4 times 6.4 is 40.96. We went ahead and calculated that. And bringing it down. You see where we got it from. 6.4 squared, right? And so we went ahead and calculated it. You can do it in your calculator. 6.4 times 6.4 is going to give us the 40.96. So we've got that. That's there. Brought that on down. And bring down to 12. Now, this is set over 3. That's what I was showing you. So now, we can just carry out the multiplication straight across. See here? Just multiply everything. Because it doesn't matter when you're multiplying what position it in. It's like saying 1 times 2 and 2 times 1. Same thing. Okay? So, when you multiply 1 times 3.42, 1 times 3.14, and then that times 40.96, and then that times 12. Let me get my blue pen. Here's what your answer would be. Go ahead and put in your calculator. Your answer would look like this now, or the problem will look like this. V volume equal 1543.37. See, I'm on the next line. Over what? 3. Bring the 3 on down. Okay? And so now what do we do from there? Well, 3 divided into this. Okay? 1543.37. Put it in your calculator. Yeah, so what we're going to do is just go 1543.37 divided by 3, and you will get this answer. 514. 514.45, and the number continues. But I wrote it like this because I'm going to show you something here. We know that the decimal 0.45 is not 0.5 or greater, so this would be 514. If it was 0.5 or greater, where you see 0.45, if it was 0.5 or greater, then the 514 would be 515. Why am I saying that? Because the problem said, look back and read the problem. It said, the question said, to the nearest cubic centimeter, what is the volume of the coin? So we got to get the nearest. So we're going to round that to 514. If it was 0.5 or higher, we would round it up to 515. But since it's 0.45, then this is 514. That's your answer. Or I was showing someone this. I said, or you can convert 1/3 to a decimal. That's what I was saying. We did the 1 times 3.14 times 40.96 times 12 over 3, and that's how we came up with this. You could have went, even when I got my final answer, 15.4337 divided by 3. We could have said divided by half. But if you were going to do that, convert that, not by half, by 1/3. You would have to take that third, I'm just showing you, and you would go equal, convert the fraction to a decimal. Take this number 3 and divide it into here. If you want to do that, I don't see why. I just showed you an easy way to do it. So, but I'm just showing this to you. 0.333. And if I multiply that, 1543.37 times what? The decimal. 0.333. And you can put this in the calculator, you'll see. And that's going to equal 514. Get the same answer, 0.40. Nearest centimeter, since that's not 0.50, it's 0.40. The answer is going to be 514. So you could have multiplied it either way. But just keep what I gave you initially. I just wanted to show you how you could have used that 1/3 fraction. Okay, that's how you do that problem. All we did was wrote out the formula for getting the volume of a cone. And then we plugged in the values of what, see, this says 1/3 here. Pi, radius, square. They gave us the value of these things, and h is height. So over here, what did we do? 1/3 pi. The radius is 6.4 squared. We just plugged the values in, and then the 1/3, we kept the 1 up here, put the 3 down here. It's the same thing. Because if I was going to do 1/3 and convert it to 0.333 and multiply, it's going to come out the same thing. And then we just carried out the multiplication. You can see right here, that long arrow all the way here. We just carried out the multiplication all the way across. 1 times 3.14 times 40.96 times 12. Put it in your calculator just like that. 1 times this times 3.14 times 40.96 times 12. Because it don't matter when you multiply. You can put it in any order. It's going to come out the same. It's like saying 2 times 4 or 4 times 2. It's the same. Okay, and then once we got that set over 3, we got our answer. It was 1543.37. 1543.37 over what? 3. All right? And that equals 514.45. But your book said to the nearest centimeter. Because that decimal is less than 5.5, we round it up to, keep it rounded, or we round it down to 514. Because if that decimal is 0.5 or higher, then the 514 would be 515. But it's not 0.5 or higher. Okay, there we go. That's your answer. We're going to stop there. Move on to problem number 38.